to start our study of section 2, that's chapter 2, section 1, 2.1. And as always, whenever we start a section, we always start by doing the learning target. And the learning target in this case, the daily learning target, is to express rational numbers as decimals and decimals as fractions. So we're going to be switching back and forth between decimals and fractions. We're going to learn how to switch back and forth between the two of them. However, we've got a few terms that we have to cover first. So these are new vocabulary words, and you will be responsible for them on the test. So the first term is rational number. Rational numbers are in the form of a divided by b, which is a fraction, where a and b are integers, and b is not equal to 0. We cannot have 0 in the denominator. It's an undefined term, so you can never have b in the denominator. Second term you need to have is terminating decimals. Is a decimal whose digits in. We have repeating decimals, we have non-terminating decimals that just go on with differing numbers in no particular order for a long time, forever. And we have terminating decimals. So terminating decimals are ones that have an end, And our last term here is repeating decimals. I guess we have two terms, sorry. Repeating decimals. Repeating decimal is a decimal whose digits repeat in groups of 1 or more. We'll do some examples of those. For example, we can have 3.3 and we put a bar over it to show that it's 3.33333 and so on, that the 3's repeat. The bar indicates that it repeats. We can have numbers like 2.72 with a bar over the 7.2. That means it's 2.7272272 and so on. The bar indicates the numbers that repeat. Bar notation is used in repeating decimals and is the line or bar that is placed over the digits that repeat. So it indicates the ones that repeat. Here's a key concept. This concept is one that you really need to learn, all right? Rational numbers are numbers that can be written as a fraction. In algebra, we say that by saying a divided by b, where a and b are integers, and b is not equal to 0. B is not equal to 0. Okay? So here's some examples. We write 3/16. Fractional form, it's a rational number. We write 3/16 as a decimal. We're going to take 16 and divide it into 3. We're actually going to do the work it out here. 16 won't go into 3, but it will go into 30. It'll go one time. 16 from 30 would be 14. 6 will go into 140, and I believe it'll go 6 times. It'll go more than 6 times. Let's try 8. 8 times 6 would be 48. Carry the 4. 8 would be 128. That looks like it'll work. 10 would be 12. 16 will go into 120. 16 will go into 127 times. 7 times 6 is 42. 4. Go 8. How many times will 16 go into 80? About, let's try 5 times. 5 times 6 is 30. Carry the 3. 5 times goes exactly 80. So that's 1.875. 0.1875 is 3/16 written as a decimal. All right, let's do the same one down here. Let's do a different one down here, but let's do the same thing. 1/16, we take 16 and we divide it into 1. It won't go into 1, but it won't go into 10, but it will go into 100. It'll go into 100 6 times. 96, we subtract and get 4. 16 will go into 40. It will go in there 2 times. And 16 will go into 80 rather 5 times. So it's 0.0625 is this number written as a decimal. Write -3 and 2/16 as a decimal. -3 and 2/16 is a decimal. Well, the first thing I need to do is go from this mixed number to a complex fraction. So I'm going to take 3 times 16. That would be 48, plus the 2 that's already in the numerator. So it'd become 50 over 16. All right. Then I'm going to actually do that division. 16 will go into 50 3 times. 16 will go into 20 1 time. 16 will go into 40 2 times. 16 will go into 80 5 times. So it's 3.125, and of course it's negative because our original number was negative. If we write 5 1/9, 5 1/9 as a decimal, first of all, we're going to make it into a complex fraction. We're going to go 5 times 9 is 45, plus the 1 that's already in the numerator, so that would become 46 over 9. And we're actually going to do that division now, 9 into 46. Well, 9 into 46 will go 5 times, that's 45. 9 will go into 10 1 time. And I can see that it's going to be a remainder of 1 each time, so it's going to be 5.1 repeating, 5.1 repeating. So 5 1/9 is 5.1 with a bar over the 1 because it repeats. Here's the same thing we're going to do, but we're going to do it in a word problem this time. A farmer loses the fruit on 8 of his 15 orange trees because of unexpected freezing temperatures. Find the fraction of the orange trees that did not produce fruit. Express your answer as a decimal rounded to the nearest thousandth. Well, 8 out of the 15 trees did not produce fruit. So I'm going to write that as a decimal. I'm actually going to do the division. 15 will go into 8. 15 will go into 8 5 times. Or 15 will go into 80 5 times. 15 will go into 50 3 times. And I can see that it's 0.53333, and so on. My 3 repeats. Well, it asked me to do this to the thousandth place. So here's tens place, hundredths place, thousandths place. I need to look at the digit that's just beyond that. The digit just beyond that is 3, so it's less than 5, so this rounds down, so it becomes 0.533 of his trees did not produce fruit. In their 8th grade science class, 5 out of 22 students did not turn in their homework. Find the fraction of students who did not turn in their homework. Express your answer as a decimal to the nearest thousandth place. Well, 5 out of 22 didn't do their work. So let's take 22 and divide it into 5. 22 into 5, it will go 2 times. That would be 44. I subtract and get 6. 5 will go into 60. Still just 2 times. 60 minus 44 would be 10, would be 6, 16. 22 will go into 160 probably 7 times. So let's try 7. 7 to 14, carry the 1, 14, 15. And I can see that it's 0.27. I'm sorry, I miswrote that. It is 0.227 with a bar over the 27. That means it is 0.2272727 and 27 and so on. Another way, so I'm going to round this to the thousandth place. This is the tens, the hundreds, the thousandth. This number is less than 5, so therefore I go 0.227 is my answer. 0.227 is my answer. Last slide for this. I'm sorry, no, there's another slide after this one. Right, 0.32 is a fraction, so now we're going to go the other way. We're going to go from decimal to a fraction. From decimal to a fraction. 0.32 becomes 32 over the tens place, hundreds place, 32 over 100. I look for ways to reduce this. 32 over 100, I can divide 2 into 32 and get 16, and of course 2 into the denominator and get 50. So I've got 16 50ths. I can still divide by 2, and I can get 2 into the 16 will give me 8, and 2 into the 15 would give me 25. I don't see any common factors between 8 and 25. So 8 25ths is my fraction. Write 1/16 as a fraction. I take and I write 16 over the tens place, the thousands place, so tens place, hundreds place, sorry. If I write 16 over 100, I can see that 16 could be divided by 4, and so can 100. So I'll take 16 divided by 4 is 4. 100 divided by 4 is 25. So I've got 4 25ths. There's nothing in common there. There's no other common multiples, so 4 25ths is the answer. Write 2.7 with a bar over the 7 as a mixed number. As a mixed number, so as a fraction. This has got a little bit of a trick in it. Please let me make n is equal to 2.7 with the bar over it, so the number n. Now I'm going to do something to both sides of the equation so I can keep the equality the same. I'm going to multiply both sides by 10, so I'm going to say 10n is equal to 227.7 with a bar over it. I'm going to take this fraction, this equation, and I'm going to subtract n from this side. Well, if I subtract n from this side, I have to subtract n from this side, but I'm not going to write n, I'm going to write what n is equal to, which is 2.7 with a bar over it. 10n minus n is 9n, and this one, 27.7 with a bar minus 2.7 with a bar, these two bars, these 2.7s with a bar cancel each other out, leaving me with just 27 minus 2 or 25. So now I can say that n is equal to 25 over 9. I need to reduce that as much as I can. I'm going to say, how many times will 9 actually go into 25? 9 will go into 25 2 times. And I'm going to say it's 2, the remainder of 7 ninths. 2 and 7 ninths then is my mixed number in this case. I'm going to do the same thing with 1.7 with a bar over the 7. I'm going to say 1.7 is equal, with a bar, is equal to n. I'm going to take 10 times both sides, so I'm going to say 17.7 with a bar is equal to 10n. I'm going to subtract n from both sides, but this time I'm going to use what n is equal to, which is 1.7 with a bar. 10n minus n is 9n. 17.7 with a bar minus 1.7 with a bar. These two parts cancel out, leaving me simply with 16. 9n is equal to 16. So 16 divided by 9 is equal to n. And I'm going to look to reduce that. 16. 9 would actually go into 16 one time with a remainder of 7. So it's 1 and 7 ninths. 1 and 7 ninths. Thank you. Thank you.